Hello, friends. Just a quick podcast to wrap up section 2.1. A couple ideas I want you to get. There's some talk in there about percentiles, and I guess what I want you to get from this is that the percentile for any value in a distribution, okay, is going to be the area under the curve for that z-score. The z-score, again, is the number of standard deviations above or below the mean. And this curve represents a mathematical model that we've made from a distribution. So we get a mean and a standard deviation, and that determines how spread out this curve is. So if you're asked in one of the homework problems to find the 30th percentile, I would look for a place in this table where I can find 30%. Now, of course, it's on the other page, so it'll be a negative z-score. But you find the place where one of these numbers is as close to 0.3000 as possible, and then you follow that across to get the ones digit and the tens digit, and you go up to get the 100ths digit. So if I was looking for the 70th percentile, it would be somewhere in here, and the z-score would be 0.52, a little more than 0.52. Let me show you how to get it exactly right on the calculator. So here's what I'm doing. I'm looking for the z-score for 70th percentile. All right, and from this diagram, I can see it's got to be somewhere in between these two numbers. So somewhere between 0.52 and 0.53. On the calculator, if I go second distribution, which is the vars key, the third item right here is inverse norm. So what that does is, if I put in the area under the curve that I want, so in this case, 0.7, for the 70th percentile, and hit enter, I get the exact z-score associated with that percentile. And if it was a problem like some of the ones you had in the homework where they ask you to find an exact score, you can just use the z-score formula and this newfound z-score to find the exact score. So we should try one of those. Hold on. On page 122, problem 2.7 in your book, they're talking about PSAT scores. They say the mean score is 46.9 with a standard deviation of 10.9. So you could get a question like this. What score do I have to get to be in the 80th percentile? So the first thing I'm going to do is go to my table and find the place where I've got 0.80. So as I look through here, I am going to find 0.80 right in between here. So if I go across, that is a z-score of somewhere between 0.84 and 0.85. But I'll go to my calculator and get the exact value. So when I go second, enter, I get the same thing, but I want 0.8 this time. So the z-score is 0.842 if I round. So since I know that is the z-score in question, I can go back to my z-score formula, which is right here, put in the 0.842, and then solve the z-score formula for the one score that would give me the 80th percentile. So I can do that whole thing right in the calculator. Using my algebra skills, I can say, take that inverse norm times the 10.9, and then I'm just going to end up adding that 46.9, and there it is. So I know that the z-score for the 80th percentile is right here, going to be 0.842, and I know the actual score on this test that would give me the 80th percentile is going to be 56.07, or just over 56. I'd actually have to get 57 to be above the 80th percentile. So understanding the z-score formula and understanding the connection between the area under the curve is the percentile. The z-score tells me how far I'm going to move this line, and those are the big points. I guess the other thing I just want to re-mention is what I'm doing is taking this stuff that I get from actual data, a histogram, and using the mean and standard deviation to make this curved line. And that's where we'll pick up tomorrow in section 2.2. Have a good night.